everyone, today in Integrated Math 2, we're going to go over Chapter 2, Lesson 6. Alright, so here are your objectives. Make sure you write them down in your notes. Alright, so linear and nonlinear functions. Linear functions are when we have like y is equal to mx plus b, which you should be fairly familiar with. M stands for your slope, in case you forgot, and b stands for your y-intercept. So these are the only two things that you'll need when you're trying to come up with your function. So when we get a linear function for the kind of problems that we're going to be doing, it's going to be when we have the first difference, which we'll be talking about in a little bit. Alright, then we have quadratic functions, which is when we have y is equal to ax squared plus bx plus c. And like I said, this is going to make like a U. This is called a parabola. And these kind of functions you're going to get on our second difference. Alright, then we have an exponential function, which we talked a little bit about last year. Y is equal to a times b to the x power when b is greater than 0. So this one's increasing, but we can also have an exponential decay as well. Alright, but then this one, it's not going to necessarily be for our differences. This is when we have a common ratio. Alright, so let's take a look at one of these problems. Determine the model that best describes the data. Then write an equation for the function that models the data. First of all, we see that x goes from 0, 1, 2, 3, 4, so it is consistent. That's the first thing you just want to double check to make sure. Then we go from 7 to 6. How does this change? How do we get from 7 to 6? Well, it changes by 1. And then we look from 6 to 5. Well, that also changes by 1. And then 5 to 4, that's a change of 1. And from 4 to 3, that's a change of 1. But let's say that it didn't do that. We would have to keep on going until these numbers that you have for the differences were all the same. So it could be 6, 6, 6, 6, or 2, 2, 2, 2. But you get the idea that it needs to be the same numbers. So because these ones are already the same, this would be considered our first difference. If you recall from before, from the previous slide, if it's the first difference, we know it's going to be a linear function. So if it's a linear function, we know we need to find a slope, and we also need to find our y-intercept. That way we can find out what the function actually is, not just knowing that's a linear function. So our slope is actually 1, because it has a change in y and x by 1. 1 divided by 1. Remember, this is 1. From here to here it's 1. From here to here it's 1. From here to here it's 1. So a change in y over change in x is equal to our slope. Our change in x, our change in y, first of all, is 1. Change in x is still 1 as well. Just in case you don't remember. Our y-intercept is always when x is 0 and then we find our y value. In this case, they've already given it to us, so it's going to be 0, 3. Alright, so we know what a linear function looks like. It looks like y is equal to mx plus b. Well, y is equal to m, which is our slope, which is 1, and then x plus b, which is 3. Let's simplify this. Y is equal to x plus 3. And that's it.